Okay, so let's get started. In this session, we'll be talking about Azure Machine Learning. And I want to emphasize that I know it's very difficult with such a large group to be able to follow along. And I just want to make a very important point that only when you are successful are we successful. Okay? 你们要有成功，我们才成功。So this is not a race. This is not a competition. 不是说谁最快谁会弄完。我们的目的是希望大家都可以成功，大家要了解一下我们现在在做什么。So if you have any questions, just raise your hand. Feel free to raise your hand and then ask any questions at any time. So who has already created a workspace? Can you raise your hand? Did you already get a chance to create a workspace? Okay, perfect. Thank you. If you have not created a workspace, you can go to the fastest thing to do right now is to go to that studio.azureml.net. There's a URL called studio.azureml.net. So this one, so go to this URL, this one right here, studio.azureml.net. Okay. And you should see this page. So if you have already created a workspace, you can just click sign in and do that. If you have not, click, there's a link right here that says not an Azure ML user, sign up here. So if you have not created one, you could click this link right here, this sign up here link. And then choose the free workspace option, the middle one, sign in. So if you already have an Microsoft account, such as Outlook, or if you've already registered, or even use your Azure Pass, email address, you can do that here. So so click sign in here. Actually, if you probably can use your Azure Pass to click this one too, the Create Workspace one, and then sign in with your Azure Pass credentials. So what I'm going to do today is to talk about just a very, very basic Azure Machine Learning experiment. So the goal of today is just to help you understand what Azure Machine Learning is, the various components of it, and then really just to give you what you need so you can ask the right questions. So I'll be here for the hackathon, and at least if you understand what's available, then you can then you'll know what kind of questions you can ask. So I'm going to sign in to my workspace. Okay, so sign in. Okay, what we're going to do is, so right here, just click here and then click Gallery. So this will give you a list of all the different templates that you can open. So we're not going to do any experiments by scratch. We're just going to open up a few experiments and run them today and just walk through what they are. So in the gallery, you can do a search for Titanic. So this is the example that I showed yesterday. Do a search for Titanic. And there's an experiment here that I want you to open. And the URL for the experiment is in that document. So if you go to DevDays.aml, this is the document that I asked you to open. The URL for the gallery experiments at the bottom here. So at the bottom, open the gallery experiment. The URL is right here. Okay? So in that document, in the bottom, this is the URL. And then that will take you to this one. But if you want to look for it in the gallery, it's near the bottom. Look for the one with a picture that looks like this. So once you're there, And again, you could do this later on if you want, but you can open up any experiment that you think would be interesting. But click Open in Studio. And you should see your workspace. So ideally, if you had created your workspace in the Southeast Asia region, I think that's what the instructions had said, then that's our Singapore data center. So it's a little faster to access the data in the Singapore data center. But open that experiment in the gallery, and so we'll just take a few minutes while this is opening. So again, if you're not able to open it successfully, that's okay. I'll try to go a little bit slowly so people can have an opportunity to follow along. But if you don't see it, then I can always answer any questions later. So this opens up into an Azure Machine Learning Experiment. And so on the left side, you're going to see lots of different things that you can do. So I know someone had asked earlier about image processing. I'll do an example for image processing later on. Right now, we're just going to do a very, very simple example on doing the Titanic classification. So starting off with our data set, there's a few ways to bring data into Azure Machine Learning. Because we opened an experiment that was already pre-made, this already has the data set. So you can just, on each of these modules, there you can see like the top and bottom nodes. You can just right-click on this module, right-click, and you can look at Visualize. So on those nodes, you can click Visualize, and then you can look at the data set that you have. So in this case, you can see how many rows of data you have, how many columns, and then you can get some basic statistics about that data. So we see here we have survived, how many did not survive, how many survived the Titanic based on this data set. We have the passenger class, whether they were in first class, second class, or third class. We have whether they were male or female passengers, and just the distribution of their age. So again, this is just one data set. You can bring in your own data set, the data set that you're going to use for for your machine learning experiment. So there's a few ways to bring in data sets. One is you can click this plus new button, and here is a data set option. And you can upload a data set, a CSV essentially. So you can upload a CSV file if you have CSV that you want to use. So to bring in a CSV file, you click plus new, dataset from local file right here. And so that way you can upload your own CSV file. If you have data in another location, you can do a search for what is called the reader module. So the reader module, as you can see on the right, you could have your data in different places. If your data is hosted online somewhere and you have an HTTP, if you have a URL to that location, you can just select this one. Or if there's a Hive query for you to get your data, you can also do that. You can get data from an Azure SQL database. In the next few weeks, we're actually going to have a new feature where you could access data from an on-premises SQL database. That's not available right now, but it will be available in the next few weeks. But right now, you can get data from an Azure SQL database. So for your hackathon, if you have data that is in on-prem SQL, then for the hackathon, you may have to move it to an Azure SQL database so you can access it. And with your Azure Pass, you can create an Azure SQL database. Azure Table, Azure Blob Storage, Data Feed Provider, those are different ways that you can bring in data. So in this case, I had uploaded data. So the data is just available as this module. If I had brought in data using the reader module, then I could just directly drag it to something like this, and then the data is just going to flow from, read in the data and flow there. So we're going to use the data set that's already here. So that's the data. The next module here is called project columns. And so we're doing a little bit of data manipulation, data cleansing. So in this case, this is the project columns. And whenever you click on a module, you can see that there's different options on the right. So in this case, project columns will basically, I can either drop some columns or just select some columns. So you can use the launch column selector. And as you can see here, it says basically, I begin with all columns and I exclude certain columns. So in our original data set, if we had 12 columns, then we start with those 12 columns and we exclude 4. So we will only have 8 columns left. So this is just one way of just removing some columns from the data set. So you see here, I start with 12 columns. After the data passes through here, I drop 4 columns. And now this data set should only have 4 columns left. And oops, now I need to just connect it here. And so you can see here, if I look at the, see if I could take a look here. OK, not yet. I think I have to run the experiment. The next module here is called metadata editor. So metadata, you can look for any of the modules here, but this is just metadata editor. In this case, you can do a few things. So here, for the metadata editor, what I'm going to do is rename some columns. So I'm going to pick basically these columns. As you can see here, this is already done. So what I'm going to do is select these columns here. So I'm going to select the survived, P-class, sex, and embarked columns for my data. These are just names of my original data. And then you can see the options on the right. I'm not going to change the data type, but I will make them categorical. So features such as gender or sex, male and female, there's only 2 categories, right? So when the data is imported, it comes in as strings. But I want to make them into a special type of feature called categorical, which is basically one category or the other category. I'm also going to rename the columns. So in this module, I selected 4 columns, and I'm just going to rename them, just to make it a little easier for me to process. So what I'm just showing here is just an easier way to just process the data. Okay? So I'm renaming them here. In the next module is another metadata editor module. And in this case, you can see here, all I did was select 3 columns. So I start out here, and I can just select the SIB. See, so the original data set had a column called this SIB-SP, SIBs, I don't even know what that means, and parch and fair. So if other people are going to use this data, it might be very confusing. So that's why I'm renaming them here. I select these 3 columns, and then I'm renaming them sibling, spouse, parent, children, and then fair price. That just makes it a little easier. So when you bring in your own data, then you could rename some columns or whatever just to make it easier. This experiment had the missing value scrubber. And so sometimes you might have data where you have some missing values. So in this case, let's say we had passenger data. In this case, we have passenger data from the Titanic. And every single passenger has some characteristics, right? Whether they were first class, second class, third class passengers, how much they paid for their ticket, all these different characteristics. But some data may be missing. Maybe we don't know how old one of the passengers was. Or for whatever reason, one of the passengers, we don't know how much they paid for their fare. So as I had mentioned yesterday, this is why it's so important that you need to know your data. You have that domain knowledge. And so in this case, I'm just going to replace the missing values with a median. So this is basically saying replace the missing values with a median. So for example, I have a distribution of the ages of everybody who was on the Titanic in that data set. Maybe I have 1 or 2 people who didn't have that data, it's missing, but I'm just going to replace it with a median. So, again, this is just data pre-processing. And And so this is the missing value scrubber. I won't go into this, but I can talk about this if you're interested. What this does is if you do have missing values, you can replace any missing values that are remaining. I'm just going to remove the entire row. Again, this is just more data cleansing. So this is very important when you're doing like a classification problem. You have to assign a target variable. So going back to our original data set, you have to understand what you're trying to classify. For the Titanic example, I'm trying to predict whether someone survived or not. So given all these features, the output of my model will be either 0 or 1. Right? It's going to be 0 or 1. That's the results that I'm going to get from this model. And so this survived, this feature is what's called my target variable. This is what I'm trying to predict. In this data set, because we're doing supervised learning, our data set, we have to identify the target variable. And that's done right here. This metadata editor. Again, so I'm selecting one feature called survived, and that's my target variable. And then at the bottom here, basically I'm just calling it the label. So that's the label of my data. OK. So now what we're going to do is I'm going to delete this one for now. So we're going to split the data set into training and test data. So here, you can see all my data is flowing. So everything we did was basically just to review. We brought in a data set, did some cleansing of the data, and now we're going to split the data. So you bring in a split data module, and I'm going to use 70% of the data as my training set, and I'm going to leave 30% of the data as my test set. This is the data that I'm going to test my model on. So for the training data will come into the train data module, and I'm going to use a two-class boosted decision tree algorithm. So as we mentioned yesterday, what is the thing we're trying to predict? We're trying to predict whether they survived or not. Binary classification, 0 or 1. So based on what I'm trying to predict, I'm going to choose an algorithm, which is a binary classification algorithm. And in this case, this is a two-class boosted decision tree. I know I'm doing a classification problem. So if I didn't want to do a two-class boosted decision tree, there are other algorithms here that I can use, such as two-class support vector machine, two-class neural network, two-class logistic regression. Basically, these are classification algorithms. So you can see here classification. Now, if I looked at the entire collection of algorithms I have, you can see here, you can see all these different types of algorithms, like we mentioned yesterday. Anomaly detection, classification, regression, clustering. So I have a classification problem. That's why I'm choosing one of these algorithms. So I would not want to use a regression algorithm. So that's why it's important to understand what problem you're trying to solve. And if I didn't like the two-class boosted decision tree, I wanted to use something else, then I could say, OK, then I don't want to do two-class boosted decision tree. I could do a two-class support vector machine here, and I'll just bring it in. And this is what I'm going to use for my train model. And in my train model, I'm going to select, again, the survived column. That's my target. That's my label column. And once this is trained, you can see the output of the train model goes into score model. So I'm going to train a model, and now I'm going to apply that to my test data set. So you can see here, from the split data, the training data went in to be trained using this two-class support vector machine, and the test data will come in and be scored. So I'm going to train it using my train data, apply it to my test data, and then I'm going to look at my results using this evaluate module. So I'm going to run this experiment, give it a minute and a half to run. So while this is running, any questions so far about data science or machine learning or anything like that that was not clear? OK. And so I'll be around afterwards, if anybody has any questions about what it means to create a machine learning experiment. So when you click run, what's going to happen is that these modules will all be running. And then when you see the check mark, then you'll see that basically it's complete. And so so this tells you how long it takes to run. And you can see that these modules are starting to complete. Again, data is flowing in. Your data is being cleansed. We split the data into training and testing. Right now, I'm using two-class support vector machine. But if I didn't want to use a support vector machine, I wanted to use a neural network, I could do that. For each of the algorithms, there's also the parameters. So if you're familiar with different types of algorithms, then you can try different parameters because those parameters may give you better results. If you have no idea of what parameters to use, we also have something that's called a parameter sweep module. So that way you could try a different set of parameters and then see which response is best. So now that this experiment has finished running, we can use the evaluate module to get an idea of how good the performance is. So in this case, this is an ROC curve. An ROC curve is just basically a way of evaluating how good your classification accuracy is on your test data set. And then here's some more information about it. You can see here that the accuracy was 0.772. So it's probably not the best classifier. And if I wanted to do some other things, let's say I want to compare two classifiers. Maybe the support vector machine is not a very good one. So let's bring back the two-class boosted decision tree. And this was the algorithm that Seth was talking about yesterday, just boosted decision trees. So I'm going to try and compare a support vector machine with a boosted decision tree. So I do that. I bring in the algorithm. I bring in another train model module. So I'm doing the same thing here. So you can see on the left, I'm doing the same thing on the right. So I need to bring in my training data using this algorithm. And then the output, I need to compare. But I need to score it first. So the output of the train model will go in here, and I'll apply it to my test data set. And then I'm going to put that into the evaluate module here. So what I'm doing here now, and this is in my train model, I have to select what I'm trying to predict. So the column I'm trying to predict is called survived. And then I'll run this experiment again. So we saw the results for two-class support vector machine. Maybe you want to try another algorithm. So we're comparing this with two-class boosted decision tree, just a different algorithm. And you can experiment. Try different algorithms, try different parameters to see which one will give you the best results. So now I'm running the experiment again, and it's processing the data through this flow. Right now, the square model module is running. It's taking in that trained model, applying it to the test data set. And then now I'm going to evaluate both of them. So you can see here, let's look at the result. OK, so I have two ROC curves now because I'm comparing two different algorithms. And I can see, OK, so I can see one of them is the accuracy is 0.77. And then let's see what the other one is. The other accuracy is 0.805. So you can see with a different algorithm, I was able to have an improvement in accuracy. And so that's why it's important to experiment. Try different algorithms, try different parameters. And in this case, I see that, OK, maybe I like this algorithm better. I'll choose this one. So I'm going to delete. I'm going to delete the algorithm that I don't want. I'm going to keep this one. And then run the experiment again. This is the algorithm that I like. And so I'm going to keep this one. And now let's create an API. So give this another minute to run. Okay. And for those of you who know R and Python, Seth had talked, I think Seth did the tutorial yesterday on bringing in an execute R or execute Python module. If you don't want to use the modules that are included in here, that's no problem at all. All you have to do is bring in the execute R, execute Python module, and then you can run that code with your data. So sometimes the challenges are really just getting your data into a good state, doing some data cleansing, and bringing in that data onto Azure, or hosting it somewhere so you can access it. Sometimes you might find it easier to cleanse and process your data using R or Python, and so you can also do that here. Once you bring in your data, use an execute R or execute Python module like this, and then your data comes in, goes into the execute R script, and then you can just write your R code directly to process and do any feature engineering that you want to do. So now this is done. And I'm going to create what's called a predictive experiment. So what I have here is I have my experiment that I'm doing to try to build a model. I'm trying to find the best algorithm. I'm trying to find the best parameters. And now I'm ready to host this as an API. So under here, I see setup web service here. And I'm going to create a predictive web service. And what this does is it's packaging up my experiment and getting it ready to put online. So now that's done here. And you can see that essentially it's the same thing that I had before, except I have two more modules here. One is this module called the web service input. So now this is how my data will flow in the API. So when I publish the API, the data will flow in here, and it's going to do the same thing. I'll have some project columns. It's just going to do all this stuff. And then it's going to be processed using that trained data. So in this case, I built my trained classifier, and this is the module right here, and it's going to apply that trained model onto the data that comes into the API. And then I have a web service output. So this predictive experiment tells you how the data is going to be flowing and processed in your API. And again, if you have an execute R or execute module, same thing. Data comes in, the R code is processing the data, or the Python code is processing the data, and then the output of the API is here. Now, all I have to do now is to click Deploy Web Service. And I have my API. So there's two things that we support with the API. One is called request response. So if you were building for like the IoT scenario, if you were trying to predict things in real time, you're getting sensor data, or if you're in like a factory and you're getting sensor data, or you want to get sensor data from cars or whatever, if you want to get a response very quickly, then you use the request response option. Basically, you send data to the API and you get a request back immediately. We also have what's called a batch execution process. So this is more for if time doesn't matter as much. Maybe you have a lot of data you want to do predictions on. Maybe you have every single day you're trying to process the transactions from your store, and you may have 1 million transactions that you want to process. You don't need the responses in real time, but you have 1 million rows of data, maybe in like a SQL Azure DB. Then you can use the batch option. So that'll take the 1 million rows of data, send it to machine learning to be processed, and then it might take 15 minutes or something, and then you'll get the results back. So you can do immediate response or batch. So we have this is information about your API. So once you publish the API, you can click the request response, and that will give you the REST API URL. This is the post URI right here. And so now you can use this in your app. You can use this in whatever you want. You have an API that you can call. We also have sample code right here at the bottom of this page. We tell you what the input is, what the output is, what you get in the output, and we also have sample code. So this is code that you can directly copy and paste. This is C# code. You can directly copy and paste this code into your application. Whether it's C# or Python or R code, again, this is already code that you can use to call that API. The only thing you need to do is to add in your API key, which is right here. So you can copy your API key, and then you can call your API. So going back to some of the other things on the experiment, I also want to make you aware of just some of the other modules that are available that you may want to think about using. So we had talked about the reader module. The reader module, which gives you an ability to read in data from various data sources that you might want to use when you are you're doing your predictive experiment. We also have what's called a writer module. So in this case, you can have data that you want to put output. So imagine you have an entire workflow where you get in data, you need to send it to machine learning, and you have machine learning results that you will need to use for some other data processing. So machine learning can then write your data somewhere, and you can use that, and you do that using the writer module. Again, the writer module can write data to a SQL database, or Azure Table, Azure Blob Storage, or you can embed a Hive query and then use HDInsight and to be able to get the data into there. So that's another option. In your predictive experiment, so the predictive experiment, this shows what's happening in your API. Your data is flowing in, it's getting processed. You can also use your reader module. For example, let's say in your experiment, you have data that you want your customers to send in or you're calling your API with, but maybe you want to compare that with other data. So one scenario is, let's say you have an app and your customer is buying something on that app, right? So and based on what the customer is buying or what the customer put into their shopping cart, you want to recommend other items to that customer. So the data that you get to the machine learning API may only be the customer ID and what the customer put into their shopping cart. But in order to have a better experience for the customer, you want to understand more about the customer. So you could actually bring in a reader module, in this case, and the reader module could then access a database, your customer database, right? So now the customer is buying, a box of diapers, and the customer's name is Darwin, and so that's the only two pieces of information that you have. How are you going to recommend to Darwin what else he should buy? Well, then you could call your customer database, and now you know, okay, Darwin is a 40-year-old male, and he's bought lots of diapers in the past, but he also buys lots of beer, right? So that's like stuff in the customer database. So you can join that data with the data that you have right now, and you can say, well, maybe we could give him a better recommendation based on what we know about him. And so that's one example where you can use the reader module. And so you can also look at the entire list of modules that we have here. So you can do basically some data format conversions. So let's say you bring in data, you can just convert it to different types of data. You can do there's feature selection. So if your data comes in, you might want to do some feature selection, or you want to do some feature aggregation. Machine learning, I had talked about. These are the algorithms that you can use on the data. Python and R, statistical functions. So let's say you bring in some data and you want to compute some linear correlation, or you want to add or subtract or combine values. So again, these are just all these things that you can do. So if you want to do some more complex things, sometimes using the modules may be difficult because you have to bring in so many modules and there's lots of things to do. R and Python might be easier. Just bring in your data, run this R script where you do everything in that script, and that could be your data pre-processing. Also, text analytics options here, if you want to do any text analytics. And then these are just basically your web service outputs. So this is just an example of now we have an experiment. We have all the data that was processing. We chose an algorithm, and we published that as an API. So this is this is just basically an example of pure data, from that's tabular data. So if you, one of the, I think somebody had asked about image processing. So we also have an experiment for image processing. Go back to the gallery. If you go back to the gallery here, and you can do a search for image. Whoops. And again, this is what I recommend you do. So go to the Cortana Intelligence Gallery, look under experiments, and then just look around for anything that might be interesting to you. Just open up that experiment, and then you can open it in Studio, and then you can modify it so that you don't have to start from scratch. If you're trying to do a binary classification, look for a binary classification example, replace the data with your data, replace the algorithm with a different algorithm, change up the parameters. That's just the easiest thing to do. Right here, we have an experiment for face detection. And so again, what you can do is just open it in Studio. So I'm just going to do that right now because I already have it created. So in this face detection face detection experiment, there's a module called import images. And you could just search for that here. If you look at import images, you can see that there's a class of modules for OpenCV library. Right now, it's still a little bit limited, but at least you can import an image. So, so from this import image, basically, the image will either need to be in your in Azure, your storage, or it could be on a public location. So, and this is the image that's going to be brought in. We already have a pre-trained cascade image classifier. We already have this algorithm that does facial detection, and this is just one of the modules that we have. So based on that module, based on that pre-train, it's going to go and score it against this import images. And here we have an execute R script. It basically does something very simple. It just tells you what the label is, whether it detects a face or not. But the illustration here is that we're able to import an image into Azure ML, and then what you can do is you could just directly, you can run it through execute R or Python. So any R or Python libraries that does image processing, you can do that here. One other thing I want to show you is in your web service, you have the ability to add parameters. So in this case, we have, going back to our experiment, so let's say you wanted to add some parameters to your API. So here's my experiment. The data comes in. The schema, so basically the way that it looks right here, even though this data set is here, the only reason this data set is here in the predictive experiment is because we need to know the schema, and that's all it is. But really, the data comes in through here based on that schema. So for each of these modules on the right, you have the ability to add a parameter to that module. So let's say in this data, I wanted to add something to everybody's age. So so right here, what I'm going to do is add a module. And let's do a math operation, apply math. And so I'm changing up the data a little bit. So when someone calls the API and they're trying to predict whether someone will survive the Titanic or not, they're going to add someone's age, right? Age is one of the features. But let's say in my model, I think, well, I'm going to change up that feature because I think it's going to help me give better predictive results. So in this case, I'll just do a basic math operation. I'm going to or let's square it. Yeah, let's just square it. And so I launch. Oops, sorry. Let me see if I could. operations. OK, I'm just going to do a basic add. And I'm going to add, let's say here I'm going to add 3 years to the age. OK, very, very basic thing to do to the age column. And so, so in this case, I'm going to select the age column. OK, so this one. So I'm selecting the age column, and I'm going to add 3 years to everybody's age. OK, so that's just the thing I'm going to do in my experiments. But in here, you'll see on the right, if you see these 3 lines right here, you can make that as a web service parameter. So I can set that as a web service parameter. So now, when people call the API, they're going to provide the age as one of the features. If they don't set that parameter, I'm just going to add 3 because that's just what I'm doing. But when you call the API, you can also change up that parameter. You can put in another number. Let's say you put in 5. So now the data comes in, and you'll add 5 to the age. So this is just a way to add some parameters. And so you can see and explore the different types of modules and the different types of parameters that you could use for those modules. So, so math operations especially, but anything else. Another time these parameters are used is when you might need to access different data stores. So especially in the reader, we'll go back to the reader module. So in this reader module, let's say you have data that you're accessing data in Azure Blob, or even, let's see, Azure SQL. So let's say you have a bunch of different SQL databases that different departments have in your organization. There's the there's the Asia team, there's the North America team, the Australia team. They have different SQL databases of the customers of your company. And so the Azure SQL database is where you need to get data about the customers. And so when you call the API, you can actually here add a parameter for the database server name, the database name, et cetera, server user account name and password. So now, when you call the API, you can also pass in this information about the Azure SQL database, and then that will be used to read in the data. That way, you don't have to hard code a specific database when you're using your web service. You could just pass it in as a parameter. So I think that's a basic overview of the different modules that are available in Azure Machine Learning. And then just some of the things that you can do from a web service input perspective using the RRS, which is basically request response, fast responses from the API, or batch processing. And again, from a consumption perspective, I think the easiest way to test your web services, if you just go into the web service dashboard, again, you'll see the URL. So you could just, if you're doing something in RStudio, if you're doing something in C# or something, you can just use this right now and call your web service. Another easy way that I think that I like is just using Excel. So you can just download an Excel workbook right here. And within this Excel workbook is an add-in. The add-in is already part of the Excel workbook, and it's already connected to that web service. So by opening this, I see that web service right here. I can just click on it, and then and I can already use it. So now I can just click Use Sample Data, and you can see here that from my web service, I already know what the input schema is, and then all I have to do to test my web service is just select the data, tell it where to put the output. And I think this is just a very quick and easy way to validate that you're getting the right data and you get the right results. So now you can see here the scored labels and the scored probabilities right here as part of the output. So you also probably noticed that I got a bunch of the input parameters here as part of the output, and that's just because of the way that the web service was set up. So if I wanted to take that away, So going back to my experiment. So right now, basically, you can see here in the score model, the output, this is directly what's the output to the API. So let's say I wanted to remove some of the columns. I don't want all the input columns as part of my output. So I can use the project columns here. And so before the data is returned, then I'm going to drop some of the columns before it goes back. So in my response, what I'm going to do here is I'm going to start with all columns, and then I'm only, actually no columns, and I'm only going to include the scored labels and scored probabilities. So I'm going to run this experiment again. And what I'm doing is I'm just removing some of the columns. So the only two columns that that respond are the scored labels and the scored probabilities. So you have to run the experiment each time you're done, and then you have to republish the web service. So and then if I call the web service again, I'm only going to get 2 labels back. Another question that came up earlier was about retraining, and it's a little complicated to explain here, but I will explain the concept. Let's say you have a model, again, where you want to predict, let's see what's a good example. So we'll continue with the Titanic example. You have an API that you published, and people are sending data to it, and you get responses back, right? Could be Titanic. Maybe it's fraud detection. Maybe you're trying to estimate fraud or credit risk. And you have this API that's published, but the model that's run is always the same model. If you send it the same data, you'll get the right response back. But how can you improve it? So we also support what's called retraining, where if you have new data coming in, let's say in another month you have more data, you understand your customers a little bit better, you have a better idea of who's a high credit risk and who's a low credit risk, then you can run that data through the experiment again, and you can do this programmatically. There's an SDK that you can do this. Run the data again, get the output results, and then you can see, oh, this new data helps my model become more accurate. And so I want to replace my API with this newly trained API, with an improved API. And so we have an SDK where then you can replace that model in your API. And so now, when people call your API, nothing changes for them, but they get a new and improved model. So we do support retraining on that. So that way you could make sure that the model that you expose to your app will always have the latest and greatest and the most improved function, improved accuracy based on what you think. And so this is a very deep dive focused on Azure Machine Learning. But in terms of the how you want to stitch all this together. From a hackathon perspective, maybe you just want to publish an API and then send data and just get the responses back. And that's perfectly fine. Darwin had talked a little bit about using stream analytics. So if you're interested in doing something that's a little bit more advanced, I would say just go back to the gallery. We try to make it as easy as possible to try to get you started as quickly as you can. So under Gallery, we have what's called solution templates. And in this case, we have a few different solution templates. So let's say vehicle telemetry analysis. So in this example, what these solution templates will do, they will create a machine learning workspace, but they'll also create things like event hubs and Azure Stream Analytics so that you can hook up your data into Event Hub. Let's say you have streaming data from cars. You're trying to understand the telemetry analysis from the cars that you have. So now you just hook up your sensor data to the Event Hub. That will send data to the Event Hub. And the Event Hub's already configured to Stream Analytics, so you can analyze the data in near real time. And then then you can call the Azure ML API and get your responses back. So this is just a template that has all the different components that you need for an end-to-end solution. So that's the vehicle telemetry analysis. If you're interested, again, you can play demand forecasting for energy, predictive maintenance. Just all you have to do is just click into it, open it, just play around with it, and then just see if that will fit one of your needs rather than starting from scratch. Yesterday, we had talked about the machine learning APIs. And again, just another reminder, just look for Microsoft Cognitive Services. Microsoft Cognitive Services. And these are all the APIs available to you already. So I had talked about this yesterday morning, but I'll just repeat that today. So we have different APIs available. If you don't want to build your own machine learning experiment, you can just call these APIs today. So from a computer vision perspective, in this case, you just send up an image, you call the API with this image, you'll get a JSON response back that then you can parse. And in this case, this will identify what's in that image. We also actually have a lot of characteristics about the image, not only what is in the image, whether it's racy, whether it's adult content. And so you can imagine you want to create an app that tries to protect kids, so that if kids are going to websites that they're not supposed to go to with a lot of adult content, then the images that you see, you can run through the API. It could give you a response of whether it's racy or adult or not, and then based on that, you can block the image or not, for example. So those are the computer vision APIs. We can recognize celebrities. So in this case, you could basically try different. I think we have about, I heard 200,000 celebrities. So in this case, you send up the image, and it'll tell you whether who this person is. So Satya Nadella is our CEO, and so you send this image to the API, and it'll tell you that it's actually Satya Nadella, our CEO. We have text in images. So let's say you had this image, and you wanted to read the text from it. So here, you can see here's the image, and the response is the text in that image. These are just some different images that are available. I mean, these are on this site are just different images for you to test, but you can use any image you want. If your image has words in it, then basically it could read the words in the image. I think one of the ideas that someone had was taking pictures of various things and then reading the numbers off that image. So you could use this API to read the numbers off that image. Generate thumbnails. So maybe, not sure if this might be as applicable to the hackathon, but let's say you have an image, then you can, it'll identify like the important things in the image and give you a set of different thumbnails that you could use. So that's from a computer vision perspective. Emotion. So emotion is what I demoed yesterday. But again, these are APIs that you can use today to build an app with. And the app that I showed yesterday morning is something that you could really build in 2 or 3 days because the APIs are available. So here, you send up an image, and you get a JSON response back. Basically, for each face, you get the coordinates of the face. You get a score for the emotion. And so here are the emotion APIs. Recognize emotions in video. And then especially that's important for this hackathon, we have a lot of free transactions. So in this case, if you sign up for this API and you want to use this API, for example here, you can use 30,000 transactions for free. So any of these APIs you can use and play around with. The first 10,000, 20,000, or 30,000 transactions are free. So you can try that. If you want to then create this into a solution that you'll use in large volumes, then there's basically a small price, like 25 cents per 1,000 transactions. So that's emotions. Face. So again, this is just not only the box of the face, but also lots of different landmarks on the face. So like in this case, this will tell you where the eyes are. These are where the pupils are. The nose tip. Where's the tip of this person's nose? Where is the left and the right part of their mouth? So all these things are just a lot of rich data that you can have, like the eye left top, eye left bottom. Lots of different landmarks on a face that it could identify for you. And then again, age and gender, but things like roll, yaw, and pitch. So is the person facing this way? person facing this way, person facing like that. That will give you an idea of where the person is looking at. So you can imagine being able to even recognize the orientation of a person's face. Face verification, this is something that's done in Facebook today, as you can probably know. But you can compare two images and see whether that's the same person. So this might have applications in some security applications. Let's say you have a security mechanism where you go up and there's a camera, and it will only let you in, but it will not let somebody else in, right? So it'll take a picture of you, it will match it up to a picture that it already has, and then you could compare the faces to see if they're the same person. So that's from the face perspective. And then we also have some video ones. We also have speaker recognition. So again, from going back to the security example, you can train it to identify various speakers. So someone who has to say the magic password in order to open something up, right? It has to recognize the person. It'll recognize the speaker. If someone else says it, then it's not going to pass, right? You can use that for speaker recognition. So that's some of the speech APIs. We have text analytics. So text analytics is, let's say you have speech or text. You can do sentiment analysis. So let's say you're trying to understand whether someone's happy or mad based on their text. We have key phrase extraction. So let's say you get lots of emails from your customers. What are they talking about? What are some key phrases that are common across all of the emails? Topic detection, language detection, and so just lots of different things that you could use here. So I'm running out of time, or I think my time is up right now. But I would recommend that you go to the cognitive services, look at all these different types of APIs. And of course, I'm here if you have any questions. And so to wrap up, I just want to say from a hackathon perspective, from a business solutions perspective, we as Microsoft, we're committed to make you as successful as possible. So we want to give you all the building blocks that you need to be able to create the amazing apps and innovative things that will be really impacting the world. And from the different types of options that we have are finished APIs. These are the APIs that are already finished. These are the APIs that you can call directly today that you can build your solutions on. If you want to do something more custom, you can build your own machine learning experiments, like I showed you with a Titanic or a face detection today. Customize the actual experiment. And you basically have the whole spectrum of creating a solution quickly or customizing it as you want. But again, we'll be available for any questions. And so I hope you have a very successful hackathon. All right, thank you very much. OK, so let's get started. In this session, we'll be talking about Azure Machine Learning. And I want to emphasize that I know it's very difficult with such a large group to be able to follow along. And I just want to make a very important point that only when you are successful are we successful. OK? 你们要有成功，我们才成功。So this is not a race. This is not a competition. 不是说谁最快谁会弄完。我们的目的是希望大家都可以成功，大家要了解一下我们现在在做什么。So if you have any questions, just raise your hand. Feel free to raise your hand and then ask any questions at any time. So who has already created a workspace? Can you raise your hand? Did you already get a chance to create a workspace? Okay, perfect. Thank you. If you have not created a workspace, you can go to the fastest thing to do right now is to go to that studio.azureml.net. There's a URL called studio.azureml.net. So this one, so go to this URL, this one right here, studio.azureml.net. OK. And you should see this page. So if you have already created a workspace, you can just click sign in and do that. If you have not, click, there's a link right here that says not an Azure ML user, sign up here. So if you have not created one, you could click this link right here, this sign up here link. You have CSV that you want to use. So to bring in a CSV file, you click plus new, dataset from local file right here. And so that way you can upload your own CSV file. If you have data in another location, you can do a search for what is called the reader module. So the reader module, as you can see on the right, you could have your data in different places. If your data is hosted online somewhere and you have an HTTP, if you have a URL to that location, you can just select this one. Or if there's a Hive query for you to get your data, you can also do that. You can get data from an Azure SQL database. In the next few weeks, we're actually going to have a new feature where you could access data from an on-premises SQL database. That's not available right now, but it will be available in the next few weeks. But right now, you can get data from an Azure SQL database. So for your hackathon, if you have data that is in on-prem SQL, then for the hackathon, you may have to move it to an Azure SQL database so you can access it. And with your Azure Pass, you can create an Azure SQL database. Azure Table, Azure Blob Storage, Data Feed Provider, those are different ways that you can bring in data. So in this case, I had uploaded data. So the data is just available as this module. If I had brought in data using the reader module, then I could just directly drag it to something like this, and then the data is just going to flow from, read in the data and flow there. So we're going to use the data set that's already here. So that's the data. The next module here is called project columns, and so we're doing a little bit of data manipulation. You can do a search for Titanic. So this is the example that I showed yesterday. Do a search for Titanic. And there's an experiment here that I want you to open. And the URL for the experiment is in that document. So if you go to DevDays.aml, this is the document that I asked you to open. The URL for the gallery experiment's at the bottom here. So at the bottom, open the gallery experiment. The URL is right here. Okay? So in that document, in the bottom, this is the URL. And then that will take you to this one. But if you want to look for it in the gallery, it's near the bottom. Look for the one with a picture that looks like this. So once you're there, and again, you could do this later on if you want, but you can open up any experiment that you think would be interesting. But click Open in Studio. And you should see your workspace. So ideally, if you had created your workspace in the Southeast Asia region, I think that's what the instructions had said, then that's our Singapore data center. So it's a little faster to access the data in the Singapore data center. But open that experiment in the gallery, and so we'll just take a few minutes while this is opening. So again, if you're not able to open it successfully, that's okay. I'll try to go a little bit slowly so people can have an opportunity to follow along. But if you don't see it, then I can always answer any questions later. And then choose the free workspace option, the middle one, sign in. So if you already have an Microsoft account, such as Outlook, or if you've already registered, or even use your Azure Pass, email address, you can do that here. So click sign in here. Actually, if you probably can use your Azure Pass to click this one too, the Create Workspace one, and then sign in with your Azure Pass credentials. So what I'm going to do today is to talk about just a very, very basic Azure Machine Learning experiment. So the goal of today is just to help you understand what Azure Machine Learning is, the various components of it, and then really just to give you what you need so you can ask the right questions. So I'll be here for the hackathon, and at least if you understand what's available, then you can have then you'll know what kind of questions you can ask. So I'm going to sign in to my workspace. Okay, so sign in. Okay, what we're going to do is so right here, just click here and then click Gallery. So this will give you a list of all the different templates that you can open. So we're not going to do any experiments by scratch. We're just going to open up a few experiments and run them today and just walk through what they are. So in the gallery, so this opens up into an Azure Machine Learning experiment. And so on the left side, you're going to see lots of different things that you can do. So I know someone had asked earlier about image processing. I'll do an example for image processing later on. Right now, we're just going to do a very, very simple example on doing the Titanic classification. So starting off with our data set, there's a few ways to bring data into Azure Machine Learning. Because we opened an experiment that was already pre-made, this already has the data set. So you can just, on each of these modules, there you can see like the top and bottom nodes. You can just right-click on this module, right-click, and you can look at Visualize. So on those nodes, you can click Visualize, and then you can look at the data set that you have. So in this case, you can see how many rows of data you have, how many columns, and then you can get some basic statistics about that data. So we see here we have survived, how many did not survive, how many survived the Titanic based on this data set. We have the passenger class, whether they were in first class, second class, or third class. We have whether they were male or female passengers, and just the distribution of their age. So again, this is just one data set. You can bring in your own data set, the data set that you're going to use for for your machine learning experiment. So there's a few ways to bring in data sets. One is you can click this plus new button, and here is a data set option. And you can upload a data set, a CSV, essentially. So you can upload a CSV file if you